So let's jump in and look at the first question together. So the question says, ice containing only the isotope H2 sinks and does not melt when dropped into ordinary distilled water maintained at 3 degrees Celsius. So a few things we need to look at here. It's not melting, it's in water at 3 degrees Celsius, and the isotope is H2. Remember, that means that there are 2 neutrons in this atom of hydrogen. So which statement is correct? The isotope H2 has a high natural abundance. If we look at the periodic table, and hopefully you remember this, hydrogen has a mass of about 1. So if this isotope had a high natural abundance, hydrogen's mass would be much greater than 1. It would be closer to 2. So we can go ahead and mark this answer out. It does not have a high natural abundance. We know that because the mass of hydrogen is around 1. Ice made from hydrogen 2, and we know it's ice because there's an S for solid, has a higher melting point than normal ice. Well, we know it doesn't melt when it's dropped into water that's at 3 degrees Celsius, which is higher than the melting point for normal ice. So we're going to put a question mark there. That could be true. Let's go ahead and look at our other options though. Ice made of H2 has a lower density than normal ice cold water. If it had a lower density than normal ice cold water, it should be floating right now, and it's not floating, it sinks. So we're going to cross that one out. H2O made from the H2 isotope has different chemical properties from normal water. Well, all that we did was add a neutron to our H2O, which does not change any chemical properties. Remember, isotopes in general will have very similar chemical properties with each other because neutrons are neutral particles. They're not affecting the chemical nature of the atom. So that leaves us with the only answer that could work, which is B. The solid H2O has a higher melting point than normal ice. Let's take a look at the next question. So it says, the table lists successive ionization energies of an element Z. Which is the formula of the stable oxide of the element Z? So first thing, we're looking for the stable oxide of the element Z, which means it's going to be one of these formulas, of course. So remember, oxygen always forms a -2 ion. It needs 2 electrons in order to become stable. We need to know how many electrons does Z need to give away to become stable. And we can use this ionization energy table to predict that. Remember, ionization energy is the energy it takes to remove an electron from an atom. So when we have a table like this, we're looking for a large jump in energy between these electrons that we have here. So between the first and second electron, our energy jump is around 1200-ish kilojoules, and this doesn't have to be exact. Between the second and third electrons, we jump about 900 kilojoules. And then between the third and fourth electron, we jump about 8,000 something kilojoules. Again, it doesn't have to be exact. Between the fourth and the fifth, a little over 3,000 kilojoules. And between the fifth and the sixth, a little less than 4,000 kilojoules. So where do you see the highest jump in energy? Hopefully you caught on that it was between the third and the fourth electron. When we remove the third electron from this element Z, it takes 2,744 kilojoules of energy to do that. But when we remove the fourth electron, we skyrocket up to 11,500 kilojoules of energy to remove that electron. What that tells me is that there are 3 electrons that are easy to remove from this element. Once we go past 3, we see a huge energy jump. And that tells me that I'm no longer taking valence electrons away. Remember, valence electrons are on the outermost energy level. They're the easiest electrons to remove. Once we remove all of the valence electrons, the element should be stable. So once we remove all 3 of these electrons, it takes a huge amount of energy to remove the next one. Because the element was already stable, it doesn't want to remove any more electrons. So when you're looking at an ionization table like this, you're looking for the huge jump in energy, and that will tell you how many electrons have been removed. There's a huge jump in energy between the 3rd and 4th electron, which tells me we only lose 3 electrons. So that means that this element Z is going to have a +3 charge. Oxygen, we already know, has a -2 charge. So if we crisscross those numbers to form our oxide, we get Z2O3, which is answer C. And our last question, this one is really interesting. It says a container holds 30 grams of argon and 60 grams of neon. What is the ratio of number of atoms of argon to number of atoms of neon in the container? So instead of looking at atoms, which the question is asking me to do, which would require me to look at a large number. Remember, Avogadro's number is 6.02 times 10 to the 23rd. I don't have a calculator or anything like that, but I know that 1 mole of argon would be equal to 1 mole of neon in terms of number of atoms. 1 mole of argon would have Avogadro's number of atoms, would have 6.02 times 10 to the 23rd atoms. 1 mole of neon would also have 6.02 times 10 to the 23rd atoms. So we're given mass. We want to look at moles so that we can technically look at atoms, which is what the question is asking. So what we're going to do is use the periodic table to find our number of moles of each of these samples. So we have 30 grams of argon, we have 60 grams of neon. If we look on the periodic table, argon is made up of about 40 grams per mole. And again, this doesn't have to be exact. We don't have a calculator anyways. Neon has a molar mass of 20 grams-ish. So if we divide these, we have 3/4 of a mole of argon and 3 moles of neon. So we want to look at the ratio of moles of argon to moles of neon. So our ratio is 3/4 to 3 moles. And to get a decimal of our ratio, which is what the question wants, we would just divide 3/4 over 3, which gives us 1/4. So the answer would be A. If fractions freak you out and you can't easily divide 3/4 by 3 in your head, what you can do is just compare these ratios here. We can say 3/4 is close to 1, so we could say we have a 1-to-3 ratio, which if we have 1 over 3, that is definitely at least, hopefully you know, that's less than half. So obviously our answer is not 4, it's not 2, it's not half. The only answer that would work is 0.25. So either way, if you divide or you just think through it logically, you can come to the conclusion that the answer is A. I do hope this was helpful for you. If you have any specific questions, make sure and leave a comment. Thank you so much for watching, and be on the lookout for more examples of IB paper questions.